This video we're going to be doing one stoichiometry problem, and this is a similar type of problem that you might see on a test. So let's read this question here. It says, if you start with 108 grams of aluminum and 324 grams of HCl, how many grams of H2 will be produced? So grams of H2 will be produced. So the first thing we have to take a look at, and I've gotten some steps written out here. First thing we got to do is going to be to balance out our equation. So you may have noticed up here, I have the chemical equation, but I don't have all of the coefficients yet. And those coefficients are really important to solving these problems. So we have to start by balancing out our equation. So the way we do that is we're going to start with assuming each one's 1. So I'll write it in pencil, and we're going to have to erase these as the coefficients change. So I wrote it pretty lightly. So it's going to be 1 all around, and we can find out how much of each element we got. So if we take a look at aluminum on the left side, there's hydrogen, and we got chlorine there. So on the left side, we got 1 aluminum right here, 1 hydrogen, and 1 chlorine. Let's take a look on the right side. So again, we will have the same elements. We got aluminum, hydrogen, and chlorine. In this case, we got 1 aluminum, 3 chlorine, and 2 hydrogen. So this is not a balanced chemical equation right now, because even though we got the same amount of aluminum, our hydrogens are not balanced and our chlorines are not balanced. So what we have to do is look at what's not balanced right now and balance it out. So I could take a look. Hydrogen's not balanced, so I could change that right up there to a 2. I always take a look at which one's less. This side's less, so I would just increase this number, and I could put any number larger, but I'm just going to go up by 1 because you'll always catch it if you go up by 1. So if I put a 2 there, that changes my hydrogen to a 2. And it changes my chlorine to a 2 as well. So that's great. My aluminum's balanced, my hydrogen's balanced, but now my chlorine is not balanced. So let's try to balance that chlorine out. So again, I'm going to have to change that 2 that I just put down there. We'll make that a 3. And by making that a 3, take a look at this, changing that chlorine to a 3, but it also changes our hydrogen to a 3. So now aluminum's balanced, chlorine's balanced, but not our hydrogen there. So we need to add more hydrogen to the right side. So let's do that right now. So to do that, we'll have to change this coefficient here from a 1. We'll put a 2 there. And that would give us 4 hydrogen. So we have 2 molecules of H2. Each one has 2. So that would give us 4. Now we got more hydrogen on the right side, so we'll have to add hydrogen to the left side over here. So let's change this to a 4. That'll make our hydrogen 4, make our chlorine 4 as well. Aluminum's balanced, hydrogen's balanced. We need more chlorine now on our right side. So in order to do that, we have to change our coefficients in front of AlCl3. We'll change that to a 2. And that changes our aluminum to a 2. And our chlorine is now going to be a 6. So in each molecule, we would have 3, and we got 2 of them. So we would have 6 chlorine there. Now my aluminum are not balanced and my chlorine aren't balanced. So I got to add, we'll start with aluminum here. I got to add 1 aluminum onto my left side. So I'll change this to a 2, and that will give me 2 aluminum. So that was an easy fix. And now I got to make 6 aluminum on this side. So I could change this right here to a 6. Because if that's 6, my chlorine will be 6. And if this is 6, my hydrogen will be 6. So again, now my aluminum is balanced, my chlorine is balanced, my hydrogen is not. So I will have to increase my hydrogen on my right side. So let's change this. Put a 3 there. And by putting a 3 there, that gives me 6 hydrogen. And I could always double check this. Aluminum balanced, hydrogen balanced, chlorine balanced. This is a balanced equation up here. So let's write it in. Our coefficients, we got 2 aluminum, 6 HCl, react together to become 2 aluminum chloride and 3 hydrogen. So we're going to be using these, and I'll even cut this out because we're going to be using it a lot, so I want to be able to move it around. We're going to be using this balanced chemical equation to help us answer this question. So that's that first thing we did. We now have that balanced equation. So now let's jump to our next step. In our next step, we want to map out our question. And when I say map out our question, I want us to think, what are all the steps that we got to do? So let's grab a paper and we can start writing some things down. Maybe I'll zoom out a little bit because we're going to be writing a lot of things here. And this is where the foldable comes out. So this has kind of been our map, but it's always good to write it out for each question we're solving here. So we're given 108 grams of aluminum. So that would be a starting point. Mass of aluminum. And then from mass of aluminum, we would want to go to moles of aluminum, because we have to convert to moles. We have to convert to moles in order to use our chemical equation up here. And then from that, we have to convert it to something else. So we have to look, what are we trying to find in this question? We're trying to find grams of H2. So we would be converting to moles of H2. Oh, sorry, this would be moles of H2. And then for moles of H2, you could see we're jumping to mass of H2. Mass of H2. So that's just one of the reactants we're given. We're also given the mass of HCl. So we also have to do this with HCl. So, and again, we would be following the same process. Mass of HCl. We would have to convert that to moles of HCl. And then we would have to convert that using our equation up here to moles of H2. And then we would finally do a conversion to the mass of H2. So we're given 2 masses of 2 of our reactants, and we can go through and figure out all of this right here. But what we really need to do is figure out which one is our limiting reactant and go all the way through with that one. So if we do this, we'll come up with two answers, and the lower one is going to be the correct answer because the lower one will be our limiting reactant. So the next thing we have to do, now that we have our map here, I'm going to cut it out so it's a little bit easier to see and use. The next thing we have to do is to find, and I could even move this question out for a second. We have to find the molar masses of every compound or element in our map right here of our problem. So we have, let me get some different colors for this. We have mass of aluminum. So we have to find the molar mass of aluminum. We will also have to find the molar mass of HCl. And also in this problem, we have to find the molar mass of H2. So that's what we're going to be doing next. We have to find the molar mass of all of those things. So I will write those on a paper right here. We're going to find our, might need a bigger paper. We're going to find our molar masses. And we're going to find it of aluminum. We're going to find it of HCl. And we're going to find it of H2. And we're going to need to save these for later. So let's bring this up here. And we're going to need a periodic table to do this. And we're just going to be doing it the simplest way we can, just rounding to the nearest whole number. So our first one, aluminum, just a single element there. We could see on our periodic table right here. Maybe I'll zoom in a little bit. We could see on our periodic table, aluminum is about 26.98 grams per mole. We'll just round that up to 27 grams per mole. HCl, that would be a hydrogen and a chlorine, one of each. Hydrogen's about 1.00794, so we're just going to round that to 1. So 1. Chlorine is 35.4527, so we're going to round that down to 35. It's a little bit of a stretch, but we'll round it down. And if we add those together, we'll get a molar mass of about 36 grams per mole. And then with our hydrogen, we have 2 hydrogen here. Each one we said had a molar mass of about 1. So 2 times 1 is equal to about 2 grams per mole. And we're going to use all of these numbers in our problem at some point. So we'll have them here to use for later. So we just did step 3. We found our molar masses. So now let's bring our map back here. And let's bring our question back too. because we want to use the numbers here to help us out. So when we're starting with our masses, we are going to be starting with 108 grams of aluminum. So I'm just going to write here 108 grams. And if we're starting with HCl, we're starting with 324 grams. So that would be 324 grams. So our goal now is to convert these into moles. So in order to do that, we need to divide by that molar mass. And if you have this foldable, you just flip that up and it'll tell you exactly what you got to do. Divide by that molar mass. All right, so if we look at step 4, it's convert mass to moles. So it's just moving from here over to here. So let's start with aluminum. So we're starting with 108 grams. Of aluminum. And in order to get to moles, we just said I had to divide by my molar mass. And my molar mass, we'll bring this up here. My molar mass of aluminum is 27. So I would divide by 27 grams per mole. If you have your calculator, let's clear it. We got 108 divided by 27. That's going to equal 4. We got 4 moles of aluminum. And we could write that right in here. 4 moles aluminum. Now let's do that exact same thing with HCl. So we said we started with 324 grams. That comes straight from the problem. Straight from that question. And we're going to divide it by our molar mass. So if I move this calculator, we can see our molar mass of HCl right here was about 36 grams per mole. And we could solve how many moles of HCl we got. So 324 divided by 36 is equal to 9 moles HCl. So we got 9 moles HCl. So we can put that right here. All right, so we've used our molar masses to convert to moles. Now, remember our balanced chemical equation, these are all in moles. This would be 2 moles of aluminum plus 6 moles of HCl will react to form 2 moles of aluminum chloride and 3 moles of hydrogen. So our next step, after we convert our mass to moles, our next step is to find the number of batches for each reactant. We're looking to find our limiting reactant so that we don't have to take both of these all the way to the end. If you want, you can. And you could figure out which one makes less mass, and that'll be your answer. That'll be your limiting reactant and your answer. But we don't want to do all the math to do that. So we're going to find out which of these makes less batches, and that will be our limiting reactant, and that's going to be what we go through the rest of these with. So the way we find our number of batches is going to be, and again, you could you could use this to help us. If you fold these up, the way we find our number of batches is divide by our coefficient. So if I'm aluminum here, and I have 4 moles of aluminum, and I want to know how many batches I'm making, I divide by my coefficient right here. So 4 divided by 2 is going to equal 2 batches. With that aluminum, I can make 2 batches of this chemical equation right here. Now I'm going to do that same thing with HCl. So let's see, we got 9 moles of HCl divided by my coefficient there, 6. And with my HCl, I can make 1.5 batches. So we got to think, which of these is my limiting reactant? Which one is going to get all used up first? And it's going to be the one that makes the least amount of batches here. So it's going to be HCl. So because I know that, and because I just found out that HCl is my limiting, I'll write that down right here. HCl is limiting reactant because it makes less batches. Because of that, I don't have to do any more of this, because there's going to be extra aluminum left. This won't tell me anything, so I can cross out the rest of that part of the map, and all I got to do is complete this bottom part here, and I'll find my answer, and that's because HCl is limiting. So I should probably write that down there so we remember why we're crossing this one out and going with HCl. HCl is limiting reactant. Oh, you know, and I jumped ahead because step number 6 was identify limiting reactant. So I just talked about that. So figure out the batches. Whatever's less is limiting. So now that I know HCl is my limiting, I can continue on this part of my map and convert those batches that I just calculated into moles of H2. So what we're going to be doing here is, again, you could bring out your foldable. We're at batches right now. We're making 1.5 batches. We have to multiply by our coefficient of B, which is right here, and that'll tell us how many moles of H2 we got.